Hello everyone, I am Đỗ Đình Phát, PhD student in the Artificial Intelligence Department in Achu University. Now, I will present the thesis Multi-Source Domain Adaptation for Object Detection. The paper is accepted at ICCV2021 conference. The main content of the presentation is following: previous problem, related work, method, experiments, re-implement, and new architecture. In previous thesis, only one source domain, source data, is used to train, but in the real world, data is collected from different domains, such as different cities or different times of day. However, it has a domain shift among different domains. This is an example of domain shift in the multi-source scenario for object detection. Left and right image columns are labeled daytime image and labeled nighttime image. Center image column is unlabeled dust image. And object detection is a computer vision task that predicts class and location of objects in an image or video frame. Like the image, there are objects, bounding box, and classes. Faster CNN is a typical detector using CNN's architecture. Faster CNN includes an extractor that extracts feature maps from input image. Reason Proposal Network RPN make instance may include objects. Classifier predicts the label of each proposal instance. Domain adaptation is a technique that aims to transfer knowledge learned from source domain where labeled data is available to another target domain with unlabeled data. TANN is a typical thesis using a discriminator to align source and target domain. TANN includes a label predictor through subnet to predict class of object, and domain classifier red subnet to predict label of image domain. A gradient reversal layer is fed between feature extractor, green subnet, and domain classifier. Domain classifier discriminates domains, but when the gradient is fed through gradient reversal layer, features of source and target domain are aligned, meaning feature of source and target domain is the same. The strong weak distribution alignment for adaptive object detection is an updated version of TANN thesis that use two domain classifiers. Local domain classifier networks predict the domain of each cell in the feature map to align local feature. Global domain classifier networks predict the domain of own image to align global feature. Multi-source domain adaptation for object detection using three subnet: source subnet, pseudo subnet, and source subnet I. This subnet lies strong weak distribution alignment thesis. The architecture includes a common G1 generator that extracts features for three subnets. The feature made by G1 is fed to discriminator D1 to align all domains. So the subnet I and J is made like I and J is made like the SWTA network that is chained with source domain I and J corresponding. Pseudo subnet is not chained, but is directly combined by weights of source and subnet I and J. Relation of each source subnet weight is corresponding with the value of each discriminator in the subnet. Reason of interest ROI of source subnet is aligned with the pseudo subnet by pseudo subnet learning PSN methods. The page shows the visualization of MSTA method from daytime and nighttime to dawn and dusk is a PDD 100K dataset. Source only means the method uses only the source data to train. Ground truth is the label of the example. This is strong weak and MSTA method. We see source only method cannot predict exactly object, but MSTA method have a good prediction and like ground truth. This page shows the experiments in two scenarios: cross camera and cross time. In all two scenarios, the accuracy of MSTA method is better. Source only method, single domain method, source combined method, and previous multi-source method. The thesis has no cost, so I re-implement by myself. This is my re-implement progress with good accuracy in the last steps. The detail of my re-implement is following. Inspired by the paper, I created a new network named Domain-Specific Network for Multi-Source Domain Adaptation. MSDA network uses only one generator G1 for all source and target domain. Each domain has specific feature, so using only one generator lead network gets feature badly. It is due to domain shift among all domains. To solve the problems, I make specific network. I make a specific generator for each domain. This generator can get feature of the corresponding domains separately, so they will not adversely affect each other. I also use a common discriminator for all features made by all generators. It helps to source domain and target domains align together. We see the SN method is bad accuracy. in cross-time scenario, and second, best accuracy in cross-camera scenario. The method predict exactly in visualization example. Thanks for listening, and you can see my TNS project and this video again by the link below. If you have any questions, please contact me by below email. Thanks for listening.